So let's start our class today. Bismillahirrahmanirrahim. So this week is Anova. Okay, Anova tu kita guna to compare two group or levels of an independent variable. Kita akan cari mean antara dua kumpulan yang tak berkait satu sama lain. We're going to find the mean differences between two unrelated group. Contoh, kita nak tengok antara gender dengan gender je. Okay, faculty and cost of living. Okay, maksudnya fakulti tak ada kena-mengena pun dengan cost of living. Tak kisahlah kau punya fakulti mana pun. Doesn't care where you come from, which faculty, the cost of living is always different, okay? But we want to find out the main differences between each faculty. Fakulti mana yang boros, fakulti mana yang jimat. Okay, so we want to find the mean differences between the faculty. So itu maksudnya two group that is independent variable. Okay, ataupun levels. Levels ni maksudnya macam contoh we have like low, medium, high, and then we want to find out the differences between the CGPA for a person with low, medium and high income. Maksudnya ada level kat situ, so we want to find the means difference and berbeza antara the differences between Anova with pair and independent t-test is that if dalam independent, okay, ada laser pointer. Okay. Kalau dalam independent, okay, you ada only one mean or two mean differences. Independent, okay, one ke two mean. But dalam Anova, kita ada paling tidak 3 ke 4 mean. Depend on the grouping in the variable. And Anova, kita akan tengok homogeneous. Okay, homogeneous. Homogeneous. Walaupun I pakai mouse gaming, tapi mouse gaming I ni taklah sekuat yang disangka. Homogeneous, and we also look for post hoc to key. Okay. Apa tu post hoc? Have you ever heard about post hoc before? Okay, I want to ask question first. Have you learned before about homogeneous and heterogeneous populations? Have you ever heard about equal variance and non-equal variance calculation?
Okay, for homogeneous, biasanya it means that in that particular population, it only has satu ataupun dua races saja, satu atau dua bangsa macam tu. But for heterogeneous, it has more than 3 races. Like in one particular population, it's like having a hetero, meaning that terlalu banyak races in that place. For example, kalau homo kita ada Melayu Cina or maybe Cina Indian at the one place. However, for heterogeneous, dia ada sama Melayu, Cina, Indian, Iban, Kelantan, and then we have like Wahang, we have like Tionghoa, and etc. Terlalu banyak, so that's why we call it heterogeneous.
Equal variant assume, okay, tahu Leventis in independent t-test kan? You have seen before. Equal variant assume meaning that the particular participants, okay, have equal number of size. Maksudnya kalau contoh katalah you want to do a study at the penthouse, okay. You want to find out the eating habit and the weight of the penthouse people. Okay. Kita ada siapa? Jo Dante, kita ada Sojin, kita ada Mak Rona, semua tu kan. You have all these peoples. Okay, so you want to do the study on the eating habit and the weight of these people. The number, contohlah weight dia tu katalah kan, biasanya weight orang ni kalau dalam satu populasi ni dia jarang sangat differ. Contoh dalam penthouse tu paling-paling maybe the average weight is 54 or maybe 56 or 60 macam tu. Tak akan ada yang overweight, tak akan ada yang underweight because biasanya tabiat sesuatu kawasan tu, the place, they will influence your eating habits and your weight as well. So kita yang dipanggil equal variance assume the population has equal weight among them. Bukan maksud equal weight tu it mean that if I have 54, you must also have 54. You also 54. John Tante also 54. Suojin also 54. Secretary Do also 54. No. It mean that dia punya weight tu is not differ much from each other. Okay, so itu equal variance assume. So calculation dia, kita biasa akan gunakan sama ada Tuki ataupun LSD. Okay, itulah nama term equal variance assume, cara calculation dia. Laki you tak payah buat macam mana cara nak kira dia tu. Dia ada formula dia. Okay, where we have to find the lower case, upper case and etc. lah. And then, kalau equal variance not assume adalah the group in that population does not have equal size and ada outliers. Itulah yang I masukkan terlebih berat, kurang berat, too many. Contoh for example, you want to find the average hair height in that particular kawasan, contoh kawasan Seoul we want to find the average height at Seoul. So dalam tu Seoul ni kan bandar kan, banyak orang luar datang kan. So ada tinggi 200, we have like 220 cm, 150 cm, 90 cm. So this person, dia dah banyak outlier tau, because the average sepatutnya adalah lebih kurang dalam 150 ke 170. The average should be 150 and 170. The one that outside from that range is someone that we call outliers. And if there is too many outliers, then we have to do equal variance not assume calculation. Sebab tak ada equal size among the participant tadi. Okay. So this is the term yang you akan jumpa untuk buat hypothesis lepas ini. Okay, faham apa itu homogeneous, heterogeneous, equal variance assume dengan equal variance not assume. Kalau homogeneous heterogeneous ni, dia boleh take to group, banyak jenis group. Manakala kalau equal variance assume ni, the size of the group. Size tu jadi very, mungkin ramai, banyak macam tu. For Anova t-test, astaghfirullahaladzim. Anova one-way test, okay. Anova has 3 assumption testing. First, population from which sample? I nak pakai highlight lah. Highlight warna gedung. Okay. The assumption testing is that populations from each sample should be normal. Check using normality statistic. Ni I dah ajar you dulu. Normality statistic ni kita ada, sama dia paling simple tu guna graph tu lah. We have also leaf graph, scatter plot. If want to look, if the graph normal ke tidak. Okay, ada outliers ke tak. So the population mesti normal distribution. Okay. And then the second one, each group score should have homogeneous variance. Maksudnya di sini adalah, tutup tingkap tu, you want to lalu. Sekejap tak silap tutup yang benda tu. Weh, kenapa? Cicah. Sorry. Tutup yang tu juga.
Amboi,
Tak ada lah, you want to turun naik. Okay. Sorry. Boleh bab aurat ni we have to particular take care sikit So let's continue. Okay, each group score should have homogeneous variance, equal or not. Okay, maksudnya homogeneous variance and then kena ada equal variance assume. Okay, so benda ni kita akan tengok dekat Levin table nanti. Okay, homogeneous saya cakap dia mesti sama. Okay, the population only have like itu kalau boleh not too many group in that particular place. And then the third one, sample must be independent. Okay, ini kepercayaan. Kita believe that the participant are independent from each other. What is meaning by independent from each other? Maksudnya when you start a research, you want to scout participant for your study. Okay, I want to study the the level the apa tu macam cakap the frequency of adultery. Tahu adultery kan? Curang macam sebut dia adultery Idul Fitri adultery how to pronounce adultery. Okay, adultery, the frequency of adultery among guy. Okay, you want to find out the frequency of adultery among lelaki ni kan, you want to know the factors and everything, macam mana dia boleh curang, kenapa dia curang and etc. Okay, dia independent maksudnya you tak cari, you mesti scout the participant tu semua daripada berbagai background. For example, I want to find the adultery among guy tapi I scout my family members. Abah I, adik I, my brother, my uncle, my auntie. My auntie pula curang kau. Contoh dah okay. Contoh, yalah, my family members, my neighbor lah apa. So, the participant is related to each other tau. So, it's not independent. The sample is not independent kalau macam tu. Lepas tu, participant pula ada bias. Okay, contoh bila you scout participant ni katalah dia memang suka lelaki curang kan. So dia ada bias ke lelaki macam ni mesti curang. Okay, so we just believe that the participant are independent from each others. Okay, so isn't that the participant is not related to us, and then there is no such thing as bias, and there is no someone influencing others to answer the question A. So for this number 3 we just believe. Okay, for number 2 we have to look at Levin table. Levin table tu kat mana? I will show you later on. And then check using normality statistic for population is normal ni. Okay, itu kita boleh tengok daripada table lah nanti. Okay, we can do the normality test semua tu. Okay, so if you have to choose assumption testing, yang paling senang is you can choose like 1 dengan 3 lah, because this is more related to data, the method how to scout the data. Kalau yang nombor 2 ni we have to check on the result later on. Okay, so usually orang memang akan nak senang kan, ni pun boleh, this also can. Okay. For independent t-test pun ada 2 variable that are not related to each other, right? Yes, sama je. Cuma bezanya dia punya grouping and kita tak tengok dia punya mean difference. Okay, Vanessa Cheng. For the assumption testing is a criteria that we set ourselves. Okay. It's not the criteria that we set. It is the criteria that needed for that test. Contoh, you want to choose Anova, so you have to fulfill these 3 requirement at least. Okay. Sama juga macam you nak buat independent test, you have to make sure that the Astaghfirullahalazim. Okay. You have to make sure that the data fit with these 3 requirement. baru you boleh proceed dengan independent ataupun uh, independent ataupun Anova ke, pair ke. That is meaning by assumption. It's a criteria that they said that our data has to fulfill. Okay, lepas tu independent test pun dua variable that are not related kan. Ya, dia tak related. But because we want to just to find the differences between the group. Macam tu. And dia boleh dua je pada satu masa. Independent test ni macam tak best scale lah. Okay, Anova ni dia lagi besar. Kita akan belajar step to do Anova. Okay, dia macam ni lah. You choose analyze, compare mean, one way Anova, masukkan race dengan mark, lepas tu pilih homogeneity variant, choose two key, post-hoc. Okay. Jom, kita start. Sorry. Okay, we use Anova 1. Go to data view. Click analyze. We click compare mean. One way Anova. Okay, I repeat again. We go analyze. Compare mean. One way Anova. Click. Okay, so dependent list is the mark because kita nak cari differences between the mark among the races. Kita ada 3 races, which is we have Malay, Indian, lupa nak tulis, satu Malay, kenapa tak boleh pesan? Oh. Okay. Sini. Tiga. Indian. Itu tak sebab I membesar zaman Mahathir kan. So I used to with this what we call macam cantik lah bahawa Melayu pun malas. Melayu mudah lupa. So that is the thing that I'm getting raised with because I always follow Mahathir. So bila I tahu I Melayu and I always heard that kind of thing, dia menyebabkan I eager nak compete dengan orang lain because I don't want to be labelled as Melayu pemalas. So that's how I went to university and then I do my job later on. So far, sebenarnya tak ada pun ada races panggil Melayu pemalas. It's just that the way that Mahathir describe it making me believe that Melayu tu pemalas. Okay? So it's just me je lah. Okay, let's continue. So kita ada Malay, Chinese and Indian. Okay, as a factor, 3 races and then the dependent mark here kita letak sebab dia bukan dependent list, is not dependent variable Okay, it doesn't have the same meaning. Dependent list is the one that we want to find the differences. Factor ialah the group that we want to look at. Ya, group apa kita nak tengok? Dependent list is apa perbezaan yang kita nak tengok? What are the differences that we want to see? So tak payah sentuh kontras. Ni apa? Okay, kontras ni adalah okay, related to kita nak cari factorial design data tu kan. Okay, like katalah kita ada data sets and we want to find the differences between the group, the contrast between each other. Like kita ada dia punya apa model dia, kita akan tengok dia punya ada error. So we want to find the differences dalam term of the differences between the population tu. So kita buat lah, dia ada few ada linear, quadratic, cubic, for ini you all tak payah belajar. Okay, sebenarnya ini we rarely use in the analysis. Okay, so kita biasanya akan guna post hoc. Okay. Post hoc, ni I cakap kan, SSG, Bofreni, SIDAC semua ni kan. So biasanya kita pakai, usually we use post hoc to key. Okay, apa tu post hoc to key? Okay, to key is this one. And highlighter. This one. Use the standardized range statistic to make all pairwise comparison group. Set the experiment-wise error at the rate of the collection. Apalah. Okay, mudahnya the easiest way is that we will make pair for bila kita guna tu key. Okay, kita ada 3 race, right? Malay, Chinese, Indian. It will find the differences with pair. Contoh, dia akan pairkan Malay, Chinese. Apa differences? Malay, Indian. What is the differences? Chinese, Indian. What is the differences? Chinese, Malay. What is the differences? Tadi Malay, Chinese. Ni Malay, Chinese, Malay pula. So dia letak experiment rate pula, dia punya error adalah dia assume sama for every each population. Kenapa kita pakai tu key? Sebab ini adalah yang paling standardized dan most common use lah. Okay. Tapi kita ada banyak lain juga. We also have LSD, Bofreni, SIDA. SIDA tu tapi tahu kawan Sarawak pun lah. It's just the name of that people is SIDA. Skiffy, REGF, Ryan Elliot, Gabriel West. This is 4 different person yang buat benda lah ni. Okay. Ni tambah Q ni adalah quantity. Okay, SNK and etc. But yang kita hanya guna the one that you have to remember is to key. Itu saja. So to key ni adalah pairwise. Dia buat pair one by one. Macam tu. So we choose to key. Significant ni jangan ubah. We always refer to p value 0.05. Continue. Dekat option. Pilih homogeneity variant test. Because if we do this, we click at homogeneity, it will show us where lie the differences. Kat mana differences tu ada between each race. Kalau you tak ada ni, you tak akan nampak. You tahu ada differences, but you tak nampak dekat mana. Okay, so you have to check homogeneity of variance. Continue. Okay. So dekat output, so you dapat ni. There is 4 table here. The first one is test of homogeneity variant. Inilah Levin yang I cakap tadi. The Levin test. This is the second Anova table. Okay, the Anova, kita tahu dia significant different ke tak. Ini kita nak tahu homogeneous ke tidak. Okay, you have to remember. This is what I always say to my student. Dalam Anova, there is 2 hypotheses. One for homogeneous, one for Anova. However, the one that we want to particularly find out is the differences. The one that from here. Tapi to look here, you have to follow step by step. Okay. So this is kita ada post hoc, multiple comparison. Kalau you tak check tadi, ini tak keluar. If you don't take homogeneity tadi, ini takkan keluar. So ini adalah dia punya kiraan to key dia. Okay, berapa dia differences, berapa type of error dia. So apa ni? Dia cakap the group size are unequal. The harmonic mean of the group size is used. Type 1 level are not guaranteed. Maksudnya adalah, okay, kan tak balance kan because Chinese 4, Malay, Indian 3-3. Dia tak unequal. Tapi bila dia tak unequal, dia gunakan relate error supaya dia jadi significant. Itu kegunaan to key. If setakat beza macam ni, 1-2 beza, the difference is not big, they can still use diorang punya type 1 error lah kita panggil kiraan error untuk mendapatkan significant variance for that population. Significant variance pula dah. Significant difference in that population. Kalau the differences is too big, diorang tak dapat tolong lah. They cannot do anything for that. So tu kadang-kadang kita boleh dapat there is no significant difference lah macam tu. Okay, so macam mana cara how you want to report this table? Okay, kita dekat sini. Ni result. First, look here. The first step adalah kita tengok sini. The Levin statistic. Okay. Nampak? Ada merah-merah ni. So, dekat SIG ni, kita akan ada 2 hypothesis dekat sini. Okay. kita akan ada hypothesis pertama adalah for this living table, kita akan cakap the variance of homogeneity is homogeneous for H null, and for H1 the variance of homogeneity is not homogeneous. We doesn't want H1, sebab tu I underscore. Kalau boleh kita kena achieve HO ni. So macam mana nak tahu kita achieve HO ataupun tidak? We have to look at the Sij. Here, kalau the bigger than alpha value 0.05, we proceed to Anova table. Maksudnya kita akan accept null hypothesis, which is the population, the equal variance is homogeneous. Okay, I ulang. The first step, look at Sij. We have two hypotheses, which is hypothesis O, the variance of homogeneity is homogeneous, dan H alternative, H1, the variance of homogeneity is not homogeneous. Okay. And then, kita akan tengok pada deny value, Sij value. Since it's bigger than 0.05, kita proceed Anova table here. Okay. So, kita cakap kat dalam report, from the test of homogeneity variance, the alpha is 0.05, lebih besar daripada 0.196. So we accept null hypothesis, hence we proceed to Anova table. Okay. Alternative if not homogeneous. Kalau tak homogeneous, our report only stop here. Okay, from the test homogeneity, kita reject null hypothesis. So kita cannot proceed to Anova table here. Okay. Since the column ni lagi besar, so kita kena proceed Anova table. So we proceed Anova table. The second one. The second step, look at the Sij here. 0.012. Since smaller than p-value, kita proceed to post hoc table. Kalau dia bigger than p-value, kita tak boleh proceed, kita akan stop sampai sini sahaja. So, the second one, kita akan cakap from the Anova, null hypothesis is rejected. Maksudnya there exists significant difference in mark between races. Apa kita punya H null? Okay, H null kita adalah ini. There is significant difference. There is no significant difference in mark between Malay, Chinese, Indian. Kita punya null hypothesis adalah there is significant difference in mark between at least one pair of races. Okay. So, alternatively, okay, since kita dapat tadi lebih besar daripada, lebih kecil, smaller than 0.05, so we have to proceed to the post hoc table. Okay. From the Anova table, with frequency DF, apa ni cara tulis dia? Degree of freedom between group, satu koma, degree of freedom within group, and value of F and P value. Okay, itu cara tulis dia. Lepas tu ulang balik apa null hypothesis you tadi. Okay. Itu baru step kedua. Since kita boleh proceed post hoc, we proceed to post hoc. Okay, kat mana dia punya differences? Okay, the one that is below 0.05 if the one that exists differences. So kita tengok sini, between Malay, Chinese, 0.12. Okay, and then Malay Indian ada tak? Yes, 0.34. Dia lebih rendah daripada 0.05. Okay, and then Chinese Malay samalah. Chinese Indian, there is no significant difference sebab lebih besar. And then for the final, this is how we do the report. Null hypothesis is rejected. There is significant difference in mark between Malay, Chinese and Malay Indian. Okay. So cakap Malay Chinese berapa dia punya significant difference? Malay Indian berapa? Walaupun Indian Chinese partner tiada significant difference, so we have still to report the value. Okay, kita kena explain kenapa. Kenapa pula berapa dia punya not significant tu. For this group, homogeneous subset, yang ni kita tak payah kacau. Okay, so we just report until here only. Okay, so I ulang balik. The first step adalah we look at Levin. Homogeneous tak homogeneous? We look either it's homogeneous or not. If homogeneous, we proceed to Anova. Anova okay, June cantik 0.12. We proceed to post hoc. Then we make conclusion. Okay, let's start our class for today. Miss, soalan Alibah. Can we use ordinal for factor? Yes, we can use ordinal. Okay, ordinal tu yang ketiga ni lah. We going to do the total score. This is an example of ordinal where it have classes, or maybe you want to use later on low, medium, high. Strongly agree, strongly agree, the Likert scale. Okay, we have a lot of we have a lot of ordinal and ratio kan. So we can use for Anova. Kita tengok dekat, we have a total score for mathematical resilience and we going to look for the third one, ordinal. The third one lah dah. The second example, we use ordinal as factor. Okay, untuk menjawab soalan Adibah. So we go to analyze, we go to compare mean, one way Anova, class as a factor, and total score as a dependent list. Okay, nampak tak? Kat factor tak payah define pun grupnya apa, 1, 2, 3. Tak ada masalah. Okay. So you click post hoc to key, continue, option, homogeneity test. Curious kan nak tahu apa Brown dengan Welch ni kan? Kita klik je. Tapi this is not an option You have to just to choose homogeneity ni je. Yang ni I nak cuba-cuba. Okay, continue. Okay. So you look here. Okay. Beza bila kita klik Welch dengan Browsti ni kan. Okay. Dia akan ada equality test untuk tengok robust dia. Okay, kalau you nak tahu. Ni tak ada kena-kena pun. So, abaikan. I just want to look at the data. Okay, so balik mula. Go to analyze, compare mean, one way Anova, option, homogeneity, je, continue, okay. Look at the results here. Okay, let's talk step by step Your bunderal. Okay. So the first one, you get SIG 0.710, 0.710. Okay, cannot proceed. Okay, betul ya Liba. We don't proceed. So, what option? Kita akan berhenti dekat sini kan? Okay. Since kita proceed with the post hoc, so kita just cakap there is no significant difference in cost, dah. In this, ni. Significant difference between total score dengan past tadi. Okay. So itu okay. Final conclusion. Sebab kita tak dapat nak proceed post hoc because it is higher than 0.05. So, our table akan ada dua sahaja yang kita report nanti. So, the first one, kita report yang SIG ni, the Levin test. And the second one is here lah. Okay. So, kita cakap ANOVA table. Kita ulang balik ayat dekat atas ni. Okay. And then the null hypothesis is accepted. Maksudnya tak ada significant different. With frequency degree of freedom 212. And then dia punya value adalah 0.04 and your punya p value adalah 0.996. There is no significant difference score between class of student. Okay. So, the ordinal macam medium height dia punya penerimaan. So, we or mathematical, what does the okay. Untuk ANOVA, okay, kadang-kadang SPSS bukan dia tak muncul sebab demografi. You kena tengok sama ada you tidak. Okay. Sebab you guys untuk ANOVA, if you use string, it must be numeric. This is our last example. Kita akan bincangkan perbezaan between Adelaide dengan Melbourne dan Perth in terms of cost of living. Okay. So kita pergi dekat lines, descriptive status, compare mean, one way ANOVA will become factor and cost will become kita punya dependent list lah. Post masih to key, option masih homogeneity test. You click continue, then okay. Tak ada masalah. Look at your output here. Ada tak ada jawapan apa? This is not significant lah sebab 0.64. So tak mencabar. Between Adelaide, Melbourne and Perth, ada perbezaan in mean. Okay, so kos hidupnya lebih kurang je. And my friend kan dia kahwin dengan orang daripada Melbourne. Untung gila. Okay, so tak ada kena-mena. Itu sahaja. And then for your assignment ANOVA, maksudnya you have to do repeat untuk different variable. Itu sahaja. Maksudnya kalau you dah buat untuk contoh, you tanya untuk mathematics resilience score dengan class, and then you can do mathematics resilience score dengan other factor lah, other group. Okay, kalau you nampak dekat depan ni, this is assumption t-test for assumption testing for that independent t-test. Okay, assumption testing dia bukan hypothesis, betul, I said. But I also said in the previous class adalah kita assume something. Macam hypothesis, we assume something. So we assume that for the data to be selected for certain cases, kita assume dia kena ada certain criteria. We assume that it must achieve certain criteria before we can proceed with the test. So untuk independent, okay, dia ada 3 je. First, data should be interval or ratio scale. And then data tu maksudnya yang dependent variable tau, bukan yang independent variable. Yang independent variable biasanya nominal. Like you use gender, race and etc. But for the data, okay, for the independent variable, they usually scale ataupun ratio lah. Okay. And then the score should come from random sampling from the population. Okay, if in assignment, kalau dia tak mention random sampling, we just assume dia ambil secara random lah. Okay, and then the data is normally distributed. Okay, this one I already mentioned in a few time before, yang data itu normally distribute dengan cara macam mana. You see from the graph and then you nampak outliers, maksudnya itu bukan not normally distribute. Okay, for this case, they normally distribute. So, assumption testing untuk independent test, you only have to choose 2 kan? So, you can choose number 1, number 2 boleh, number 1 or number 3. Okay, tak ada masalah. So tapi 3 ni, this 3 is the one that we use for independently test. Okay. And then for the second one, okay, macam mana nak jawab the report assignment tu kan? Okay. Okay, ini bukan diberi oleh lecturer you, but this is usually macam mana I do my assignment during my degree years. So usually the assumption testing and the independently test and the graph, I do like this. Okay, maksudnya I pilih first independently test and then I include dia punya assumption testing macam ni. And then my first kan because dia cakap in the questions. Okay, kalau you nampak soalan, sekejap siapa tengok soalan semalam? Okay. Okay, kalau daripada soalan dia cakap dia kena ada 3 statistical test, at least 3 statistical test and then 2 analysis for each kan. So if I use Anova independent test dengan Pearson correlation, so for first independent test, I will do the partner between gender and growth. Okay, for the first one. Okay, and then the second one, gender and overall score. Because gross ni, this is from my questionnaire yang mana I ada value growth struggle punya score. So, bila you dah buat independent test, Pearson or correlation, you must remember that you can use the same variable but you cannot repeat the same pair for another test. Okay, maksudnya you dah guna gender dan growth untuk independent test, you cannot repeat gender and growth dekat Anova. Okay. Ataupun dekat Pearson correlation. Okay. Biasanya usually when we do a test, we doesn't repeat the same pair variable because the goal for each test is different. So you cannot repeat the same thing over and over again. Kalau macam tu senang lah. I buat race and growth untuk independent Anova Pearson. So it's not fair. We need to know another detail as well. So kalau dah pakai pen ni, tukar pen lain. So kalau dah pakai gender and growth untuk independent, dekat Pearson buat untuk gender and overall gender and value ke ataupun gender dengan CGPA macam tu. Okay. So this is how I usually do my assignment. Okay, maksudnya I letak tajuk, I letak hypothesis first, the tables and then baru conclusion. Okay. So I hope you tak ada masalah because I won't repeat this again. Dia macam ni lah. Assumption testing, you put 2 from here and then I have tissues for so far. Assumption testing untuk independent, pair test. Okay, today kita akan masuk Anova.